Hey robot makers, hope you're having a good day so far. So do you want to know how the Arduino Uno Q compares to the Raspberry Pi and where it fits in that kind of hierarchy of different Pis that are out there? We'll go into a bit more depth as well. Then this is the show for you. So let's dive straight into. My name is Kevin. Come with me as we build robots, bring them to life with code, and have a whole load of fun along the way. I must remember to speak slower. Right, okay, so let me get over to my slides. We've only got a couple of slides and I'm going to get into a bit of a demo. And we're going to do some testing as well on the show today too. So yes, how does the Pi compare? So here's a bit of a table just to give you a bit of an overview. So the Raspberry Pi 02W, I think I've got one of these just here on the desk. I'll show you that in a second. Oops, I did that disappear there. There we go. And yes, that one has a 1 gigahertz quad-core processor. It's got half a gig of RAM. Has no storage on board. You have to provide your own SD card, although you can buy those officially from a Raspberry Pi now. And it has the usual kind of dual band Wi-Fi. I'm not sure, is it Wi-Fi 4 or 5 that's on the 02W, has Bluetooth 4.2, and it has the micro HDMI and micro USB on there as well for some kind of connectivity, as well as the regular 40-pin header. And it retails for about $15 to $17 depending where you buy it from, plus shipping and taxes. So it's the cheapest of the boards we're looking at today. Then there's the Uno Q. So this one is it's twice the speed of the Raspberry Pi 02W. Has this quad-core Qualcomm Snapdragon CPU. It has a whopping 2 gig of RAM. I'm going to say 4. There is a 4 available in November. It comes with 16 gigs of eMMC storage built in, and there'll be a 32 gig version of that in the other version. I don't think they're going to have multiple versions of this. I think it's just the 2 for now, either the 4 gig with 32 or the 16 gig with 2 gig of RAM. Connectivity wise, so this comes with Bluetooth 5.1, Wi-Fi 5, and retails for $37 plus shipping and tax. And then you've got the kind of big brother Raspberry Pi Form 5 there. So Raspberry Pi 4 has between 1.5 1.8 quad core processor. You can buy it between 1 and 8 gig of RAM, and has no storage on board. Again, you've got to bring your own SD card, and it has the usual kind of dual band Wi-Fi, Bluetooth 5. Has gigabit Ethernet on board, so that trumps the Uno Q there, because that doesn't provide any kind of Ethernet connectivity without some kind of carrier board. And it comes in all kinds of different varieties of memory and therefore pricing. So the cheapest one is $35, that's 1 gig, all the way up to $75 at 8 gig of RAM. And then you've got the big daddy of them all, Raspberry Pi 5. So this is a 2.4 gigahertz, so a little bit faster than the Uno Q from a gigahertz perspective, but it's not all about the clock cycles, as we'll see in a minute. And it has between 2 and 16 gigs of RAM. There's lots of different variants of there, between $50 and $120. And it has the usual dual band Wi-Fi, Bluetooth 5, gigabit Ethernet, and so on. So you've got quite a mix there, quite an array of different boards. And you can see there immediately the Uno Q is kind of sat above the Raspberry Pi 2W but beneath the Raspberry Pi 4 from a kind of spec perspective. So really, if you're buying a Raspberry Pi 4, you're buying the 1 gig version. The Uno Q is actually cheaper because you get 2 gigs of RAM and you get that on board storage as well for the price. So we can see immediately there's a bit of a challenger there for the Raspberry Pi 4. For the Raspberry Pi 5, you can't buy one for less than $50, so immediately that kind of puts the price point above there. But we'll have a look and see how it compares as well in a second. Okay, just going to cancel that there. Oops. Well, it jumps about then. So power usage. So what I thought we would do is actually measure the power usage live on the show, so we can actually see how this is going to work. And what I've done is I bought some they used to be by Elgato. I think they're just called Eve now, and it's basically a smart plug, but it has a power meter built in, so I can use an app on my phone and we'll basically measure the power of a Raspberry Pi 2W 02W versus the Arduino Q, and we'll do it with nothing else attached, just the raw board for now, because that will ever so slightly skew it. Right, so let's get over here to the desk. You can see here I've got the Eve app installed here, and I've got 2 power meters. I've got the Pi power meter and I've also got the Q power meter. So what I'm going to do, I'm going to switch on the power meter for the Uno Q. You'll see that spring to life there. And if we now go into that one, we'll begin to see how much power that's drawing. So where it says consumption, that's what we're looking for. So it's drawing 1 watt of power. Let's see if it goes above that. And once it stops doing that kind of figure eight and the blue light comes on, that's when it's booted to the Linux desktop. So it's not gone above 1 watt. There we go. So that light's come on, and that means it's now booted to the desktop. I think once that, there we go, the heart coming on tells us it's finished. So it's only drawing 1 watt of power. So it just jumped up to 2 there just momentarily. Let's see if it drops down again. You can see there's a little chart of how it's doing. So it booted up 1 watt of power, slightly went to 2 watts there. So what I'm going to do now, I'm going to go back to the other one, which is the Pi power. I'm going to switch that on. So this is the Raspberry Pi 2W here, 02W. So you can see on the consumption, that will change in a second. So this is starting at 1 watt, and we'll see if that increases as it boots up. I think I have seen it go to about 3 watts, kind of idling there. So it's still 1 watt as it's booting up. It's not doing a lot of heavy lifting just yet. I think once the CPU starts doing some kind of computational stuff, that's where it really starts drawing the power. So as it loads up and starts running those Linux services, we shall see if that spikes at all. So it's still running about 1 watt there. So I wanted to do this live just to make sure we don't have any cheating going on. And I've just jumped back to the other one, so we can see this is the Pi. That's on 2 watts now, and I think it'll sit around 2 watts for the duration there based on my testing earlier. And we can see there the Uno is still 1 watt, so it spiked a little bit before at 2 watts, but now it's just idling at 1 watt. So we can see there, power usage wise, the 02W is pulling twice the amount of power, 2 watts, compared to the 1 watt on the Arduino Uno. I'll just leave that there. So that immediately tells us that the Arduino Uno is slightly ahead of the Raspberry Pi. It uses half the amount of energy, and that's because Qualcomm make mobile processors. They're very much tuned into making very low power devices. So that's something where the Uno kind of goes ahead from the Raspberry Pi 02W. Okay, next up. So I managed to put these in a little chart earlier. Did quite a bit of testing. So you can see there, lower power usage is where it's better. So the Uno Q is literally half the amount of power draw as the Raspberry Pi 02W. And that's just idling, just running basic Linux Debian in the background. Okay, next up then, let's have a look at computation. So I was trying to figure out the best way of running this. I did try running Geekbench, which is the kind of standard, but I couldn't get that to work on either the Raspberry Pi or the Arduino Uno Q. Maybe I'm doing something wrong there, but we'll give this a go anyway. What I'm going to do, I'm just going to jump over to B for a second, and I'm going to open up some terminals so we can actually have a look at this. So let me open up a terminal here. So this one is the Arduino. I'm pretty sure if I jump over, what I will have to do actually is just unplug that a second, plug that back into its hub, and power it back up. So just wait a second for it to do that. I basically just had to power that back up, but through the hub, so I can actually see the desktop, which is just booting up here. I've got a Raspberry Pi monitor on here. One of the questions that somebody asked earlier as well was what resolution it runs at, and it is the sort of 4K resolution. Well, this one is running at 1920 by 180 at 59 Hertz, so pretty much 60 Hertz. Right, now that that's booted up, let me see if I can log into this in the terminal and then share my screen. Once it's done that, I can just check what the just logging into the desktop there, and obviously I typed my password wrong because it's a live show. Why would I not do that? Just trying to get the IP address of the Uno. I just have to give it a second, and once it's logged in there, we can then run. There we go. So if I now go back to over here, so I'm just going to type in the password for this. So I'm logged into a terminal onto the Arduino Uno Q, and I'm going to run sysbench, which is a benchmarking software. Let me know what your thoughts are on this as a benchmarking methodology. I don't do a lot of benchmarking, to be honest, so this is kind of threads, sorry, sysbench threads equals 4, sorry. I don't know, there we go. So it just takes about 10 seconds for this to run, and what it's going to do is just generate a load of random numbers, and then I think, does it look for prime numbers within that? Anyway, what we get there is a number, so 31,694. That's the number I'm going to compare on the Raspberry Pi. So if I now go to, I'm going to have to do this a slightly different way. I'm going to have to jump back to here. Let's see if I can now log in to the Raspberry Pi and do the same thing. I'm using the Raspberry Pi Remote Connect here, just because of the way I originally set up the Uno Q. I think that's on my Starlink Wi-Fi, and the Raspberry Pi is on my other Wi-Fi. So anyway, if we run a sysbench, the exact same, so CPU threads equals 4, and then run. Sysbench threads, oh, dash threads. I thought I got it right first time then. So 30,000-ish was the number we're trying to beat. We can probably get that up on the screen at the same time, possibly. So this one does 19,378. So not as computationally powerful as the Arduino Q. So let's jump back to here. I did put these in a bit of a chart just so that you can see what these look like and how they stack up. So yes, the number I got for the Raspberry Pi was 19,030, and for the Uno Q, when I ran this the first time, I got 40,113. So it's twice as fast computationally, certainly if you're doing that kind of integer math, as the Raspberry Pi 2W. When I ran this on the Raspberry Pi 4, we got 68,700. On the Raspberry Pi 500 Plus, got 105,207. So you can kind of see there where this sits amongst its Raspberry Pi peers. I would say it's faster than the Raspberry Pi 2W, twice as fast, but about half as fast as the Raspberry Pi 4. So if you're thinking about putting a project together, these are the kind of things that you might want to look at. And Neversick Makes is asking the question there, for comparison, are both devices running headless OSs? Correct. I think both of them are running, I think they're running a graphical user interface, but there's no monitors attached. So you might be able to squeeze a bit more performance out of them, but because they're not kind of servicing any interface, I think it's quite performant. So let's have a look at a bit of a comparison and see how this stacks up then. So the Raspberry Pi 2W, this is the one we're really going to compare the Uno to, given it's kind of closest to that. So the processor is this 1 GHz quad core. The Uno Q is a 2 GHz quad core, and therefore the Arduino 2, purely off the gigahertz clock cycles, is twice as fast as the Raspberry Pi 02W. From a computational perspective, so we just ran those two Scibench scores, and you can see there the Uno Q is twice as fast as the Raspberry Pi 02W. From a power perspective, it uses half the amount of energy, the Uno Q, as the Raspberry Pi 02W. I'm going to get tired of saying that. So we're getting quite a few wins there. And then from a memory perspective, so the Raspberry Pi 02W, one of its real failings, I think, is the very small amount of memory that it has. It actually makes it quite challenging to do any kind of AI task, large language models, or anything like that on there, simply because of the very low memory that it has. So the Uno Q absolutely blasts it there with 4 times the amount of available memory. And then from a price perspective, these Raspberry Pi 02W is only $15 to buy, between $15 and $17.50 when I checked on Pi Hut before, versus Arduino Uno Q, which is $44. Is that right? $44 I think is what I saw when I looked at. I was looking at euros before, which is why I'm thinking, I'm sure that was $37. $44. You do need to buy an SD card for the Raspberry Pi 02W. You simply can't run it without one. So that's something you'll just need to think about there. So a Pi is less than a third the price. So it's one of the reasons you might want to consider a Raspberry Pi 02W is just on price alone. But in every other metric, the Uno Q is the one to get there. So viewer questions. I had quite a few questions on the video that I did the day after launch day. I thought I'd just throw them up on here just so we can answer these. So one of the first questions that Andrew asked was, does it ship with Secure Boot enabled? Can we flush our own kernels? So it does not come with Secure Boot enabled, so you can flash your own kernels to it. And in fact, if I go to the Arduino website, just get this on the browser for you to look at, and we can jump back to that here. So if we go to Discover More, we go to the documentation for the Uno Q. I think it's software. And in fact, let's jump back there, sorry. If I scroll down here, there is a, where it talks about the App Lab and the other software. I'm just trying to find the link to it. There is a flash tool, is what I'm trying to, maybe it's just on that, maybe it is on that documentation after all. So there is a tool that you can download to flash. If you basically need to factory reset, there's a tool for doing that, because I was worried I'd mess my configuration up, and I reached out to Arduino and asked them, is there a tool for that? And they're like, yeah, it's on the website. So, which I now can't find because I didn't save a link to it. Let's go for that. In fact, if we go to Arduino, sorry I'm jumping about here, I go to software. Sure there's a link to just software, all software. Here we go. So there's the regular IDE that you would buy, you would use for programming your Arduino. You've got the legacy version as well there. Then there's the cloud editor. We'll have a look at that in a minute or two. And then there's the new thing, the Arduino App Lab. So you can download that now and have a play with it. You just can't connect to a board. And here's the Arduino Flasher tool. So that's the thing that you need if you want to flash your own operating system on there, or at least restore it to the factory default. So that's where that sits there. Okay, let's get back to the other questions. Somebody asked, can you try and connect to SSH via VS Code and coding using the AI assistant? So I did try that, and it crashes when I try that, and I think it might be when VS Code tries to connect to it to install its little server software that runs on the Arduino Q. For whatever reason, it doesn't like that, and it basically just like hangs and doesn't have a good connection. We could try that if you want a bit later on, but I found that doesn't work quite yet. The next thing then, so to elaborate on my question about Quick, so this Jesse Dam had a question about why is there only one Quick connector on the board? Why isn't there like two, one for the MCU, one for the main CPU? And an example there was about if you got an OLED display. Oh, I got an OLED display. I'll just bring up this board here. This is a Monk Makes board, for example. This one has a little OLED display just there. If you wanted to connect that to an Arduino Uno Q, it's a little bit more complicated because you have to do that. You have to kind of launder the commands through Python and then use the bridge command to connect to the Arduino Sketch. And he was just worried that that might be a bit harder for regular projects. I think this is just the way that they've decided to architect the board, so it is a little bit more complicated. There is only one quick connector, but it is pretty straightforward to use. We've got a project we can look at in a second that demonstrates that. Are the App Lab software and bricks fully open source? Can we still use the IDE? Absolutely, you can use the IDE. As to whether they're open source, it says they are on the website, so that's all I can say. I think there is still work to be done to document it and publish the documents, but as I understand it, the software is open source. There was a point that somebody did make on one of the other comments, and that was, how can it be a truly open source hardware if you can't buy the chips and the chips are completely closed source? So I think I would agree with that. It's not fully open source if you can't buy the chips. You can build your own, and you can legitimately clone. For example, there's a clone Arduino that I purchased online. So that one, exactly the same form factor, can run the very same Arduino software, and because the hardware is open source hardware, that's a legitimate thing to do. So yes, lots of promises made in the official QuamCon announcement, but time will tell. So I've not dealt a lot with Qualcomm in the past, so I'm not really sure where all that's coming from. Have they got a history of not buying stuff and then closing it all up? So Stan from Texas says, how about Node Red? So I thought we would try that as a bit of a demo in a minute, so I will come back to that one. I tried installing it from sudo apt install Node Red. I couldn't get that to work, but I have got it as a Docker container, so we'll see if we can get that to work. A good question here about deep sleep mode. So I reached out to Arduino and asked directly about this one, and they said it's being documented, so there's more to come on that. That was their kind of official line. So can you wake up the MPU via the MCU and vice versa? Can you bring up and close down different chips from different perspectives? There's all kinds of scenarios where you might want to switch off the Linux part, for example, and maybe make the MCU go into deep sleep. And then wake up occasionally, and if it needs to, then wake up the full Linux computer. That would be a really cool thing if you could do that. So I'm not sure what's possible there. There's more to come on that one. I will update when I know more about that one. So Nicola has a really great question here about, do you think it'd be possible to run ROS nodes on it? Absolutely, 100%. I would say this has been perfectly designed to work with robotics. They even mention robotics in a lot of their literature. So especially for hobbyists in the robotics field. And I have actually got a robot ready to go here. I printed this one out this afternoon. So this is an Arduino robot with a shield on top, and we'll be able to connect this one up possibly later on in the show if I'm feeling brave, and see if we can run our Uno Q on a 9-volt battery. So we'll see if we can do that. Next question then from Sean is the use of Python mandatory, or is there support for C, C++, and .NET? So the answer I got back from Arduino on this one is that it is mandatory to use Python with the Uno Q, because that's just how they've designed it. It's Python, the Uno sketches, you know, the regular Arduino C, C++ sketches. So there isn't any .NET support kind of supported in the app lab, but if you want to make your own Docker container that the app lab can connect to, then you can basically use any language possible for that. Even use, I don't know, Fortran or something if you're able to make an API with that. So does it boot vanilla Debian kernel, or does it need some kind of special Qualcomm provided special patches? What does uname -a say? So we could actually check that out right now. Actually, let's run. So this is the Arduino Uno. So do I need to make that a bit smaller or wider? There we go. So uname was it -m? So it's actually it's just the regular kind of ARM64. There you go, that's kind of what it's running at the moment. So as far as I'm aware, you don't need any special patches. It's just compiled for 64-bit ARM processors. Yes, that's what I know there. If you like these videos, you want me to make more of these kind of videos, if you want me to make more Arduino type videos, definitely let me know in the comments. I know I've not done too many of those recently. And if you like this video, give this video a like. If you've not subscribed to the channel, please subscribe. It means so much to me when people subscribe to the channel. I've had a bit of a boost this week because of the Uno Q launch. So yeah, let's keep that up. That'd be cool. And I do go live every single Sunday at 7 o'clock. We're currently in British summertime, so when that changes, it'll be a GMT instead. I think British summertime is just 1 hour plus, isn't it? So yes, if you want to join the live chat, you can do that as well. Cool. Right, let's go over to a bit of a demo. So I've got more demos that we can look at. We only looked at a few of them midweek when we did the launch. So what I'm going to do, I'm going to go over to me for a second, and what I'm going to do is kind of show you some things I didn't show last time. I did try and get this up and running on. Let me show you this. If I connect to, if I launch the AppLab software, and then I share my screen, I'll show you something that we didn't look at last time. So you can see here, it's got this network button up here. So I've not got this plugged into the USB cable. I've got this connected over my local area network. So if I click on the network button, I just need to type in my password to the Arduino. There we go. And I've now got the regular kind of interface for the App Lab, so I can now play around with this. So what I will do, one of the things we looked at and I didn't quite understand how it worked, was the Hey Arduino demo. So let's load up this one. So Hey Arduino is an example that triggers an LED matrix animation whenever you say Hey Arduino, and it's detected through a microphone. So I've got this plugged into the over here. I've got this plugged into this little USB hub that's just under the camera here. This has got the HDMI output. It's also got a USB web camera. If I go to over here, you can see we've got the web camera just plugged in there, and I'm running the software just on this Raspberry Pi monitor just here. So there's the Uno Q. I've even got a little LED plugged into pin 13 as well. We'll do a bit of a demo on that in a second as well. So what we will do next then, let's go back to the software here. And so yes, this is going to basically do an animation on that little LED display whenever it hears the word Hey Arduino. So let's run this. I have downloaded this before, so it shouldn't take too long to do the compile. And again, what it needs to do in the background is take the Python code, take the Arduino sketch and kind of mush them together. So the Arduino sketch, it will compile it, flash it to the MCU, and then it will just interpret the Python code once that's ready. And it will also build any of the bricks. They're essentially Docker containers, and it just brings those Docker containers up, it loads them up, and you access them through Python, just like you would an API of a website. So you can see here the sketch is nearly completed now for the MCU. And you can see there that it's starting the app, and it's got those 3 containers that it's just loaded up there as well. Right, and once it's finished this will sort of turn that sort of bluish colour to say that it's actually running in the background. And at that point, we can actually see the animation that's on this little screen here. Once it's ready to go, I think it's still loading up at the moment. I was looking at how to do these little animations. There we go, we've got the thing running now. So if I now say, Hey Arduino, Hey Arduino, see that little animation there? Hey Arduino, it's working. Hey Arduino, and that's all it knows. Hey Arduino. So that's an example of using a few different bricks there. So I think it has, we can go back to the software on here. I go back to that example. I think when you click back, it actually stops it from running as well. We look through that Hey Arduino, and we look through there. The keyword spotting brick is a brick that's been built specifically for this. So they've got a pre-trained model that can connect to the microphone, and then it can listen for that particular keyword. So they built a large language model. Sorry, they built a machine learning model that can identify that, and that's all it can do. So there you go, that's what you need to do. Just have some kind of microphone. I've got a web camera that's got some microphones built into a hub. The hub then goes into the Uno Q, and then it can listen through that and just do that little animation on its little LED display. And you can see on here we've got some Python code. Let's have a quick look at that. So we import the utils, we import the bricks for keyword spotting, and then on keyword detection it does this bridge call. That's the thing that connects to the Arduino's MPU, so it can MCU, so it can then run that on the Uno microcontroller, and then we just bring in that keyword spotter, and then on detect it runs that code. So if we look now on the sketch itself, we have a look in that sketch. I know we bring in that router bridge. That's the thing again that talks to the Python code. The hearts frames is a little, if we open that up, this is essentially the hexadecimal values that make the animation display on the screen. So you've got a little heart, and then you've got a couple of different frames, heart 1, 2, 3, 4, 5, 6, 7, 8, and that kind of makes that sort of display animate. And then if we go back to that sketch, you can see there we play animation. There's a nice helper thing which will take an array of those frames, and then it will play them through a certain number of frames per second. And then you can simply see there, play animation does that kind of looping round. And then the actual main code then, so if awake, play animation, and then where's the bit that does the keyword detected? So that's just in there, yeah, keyword detected wake up. So if it wakes up, which is that thing there, it'll then do that animation. So if it's awake, play that animation. Otherwise, set the awake to false and then just wait there with that little heart on the screen. Cool. So that's how that piece of code works. There's a few other bits and pieces in here. There's some documentation, which is basically just the pictures for that README file there. So these assets are basically just putting that together. This is just Markdown code. If you've ever done any Markdown, you'll be familiar with how that works. That's how you display an image in Markdown. And then these are just like headings and so on. And then there's a little YAML thing which basically just tells the launcher what icon to use, what the name of the thing is, and a bit of a description and which bricks it uses. So when we go back to that example, there's the icon, there's the title, there's the description, and the bricks it uses. Cool, so that's the first one I wanted to show you. The next one then is, one of the questions that we had was, can you use the Arduino IDE? And you can do that. You can actually run that. If I go over here, I'm sorry, this is like not a very good view. I've been trying to get some software to do screen sharing direct from here, but I've not got that working right yet. But I have installed the Arduino IDE on the Arduino Q. So you can plug in another Arduino. So I could get this Arduino here, for example. I could plug this in and we could program this from the Arduino Q. So it's a bit of an Arduino inception going on there. So once that's loaded up, we can get that working. So I'm gonna just leave that plugged in there for now. There we go. And this is the 1.8 version of the Arduino software, so it's quite an old version, but you can basically get this to run the Blink. So if we try and upload that, I don't know if I need to do any other configuration, but I will see that. It's been saying use an Elgato external capture card. I have one of those for the main display when I've got my. This is an Elgato capture card. I've got some cheap HDMI ones for this overhead, for example, but there's a limit to the number that you can actually have plugged into the software that I'm using. So there we go. So it's saying where do you want to upload that to. I have no idea which USB port is the one that it's looking for there. I don't know if that was the right one or not. It's not doing its flashing thing. This was just purely a by the way thing. So you can run the Arduino IDE, you can plug in other Arduinos into this Arduino and just program it as if this is a regular desktop computer, because it is. So I'm just gonna quit that now and unplug that one for now. Cool, so that's one thing I wanted to show there. The other thing I did want to show, if I go back over to me for a second and I open up another browser, I'm going to go to app.arduino.com. So this is the cloud. I don't know if you've ever looked at the Arduino cloud software. They have a free plan on here and then they have like paid plans. I think I'm on a paid plan, and it's just how many things that you can create. A thing is a combination of an Arduino device, a sketch, and then they're kind of connected together, and you can access it as an Internet of Things thing through a dashboard. So you've got devices, things, and dashboards. So you can, when you connect to a device, you can give that device a name. So that's what all these weird Lizzie and Sheila and all that kind of stuff is all about. And I have this weather-bot down here, I think is online. That's at the back of the studio. It's just a little temperature sensor. So if I go to devices, you'll be able to see that the weather-bot one is online. If I open that one up, you'll be able to see there that it's been online all that time. I think there's a bit of a power cut there that went off, and you can see that it's it's connected up, it's online. And if we jump back to the dashboard, I think I have a dashboard for that somewhere. Well, what we can do, we can basically just edit this live demo one, and we can bring in the whatever. Yeah, there you go. The temperature's being displayed there on a little dashboard widget. You click on that edit, you can move these around, resize them, and so on. And you simply just add one of these widgets. So say you wanted to have a chart, and then you say which variable do you want to link that to. So I could say I want to link that to the thing which is the weatherbot, and I want to link the humidity, for example, to that. So we could call this one humidity. Let's just do done. So we've got a temperature chart, we've got a humidity, and then that'll start taking readings from this point on. You can see it'll also calibrate the sort of highest and lowest value as it goes as well. If I click on done there, we've then got this little dashboard. So you can connect the Arduino Q up to output things to the Arduino cloud as well. And really this is essentially dashboarding software, a bit of an online editor, and also an Internet of Things MQTT server, so you can just send messages to it. Now, why did I bring this one up? It's really to do with the sketch editing. So if I go to, let's open up a sketch I prepared earlier. So if I find Mars Uno Q, there we go. If I open up this one, so this sketch is what this little robot here is actually running. If I just connect up the battery on here, it'll sort of lurch forward for about a second. So I just disconnect that, and you can see that it's the usual kind of thing. We've got some serial prints, we've got some pin modes being set for the motors. There's a buzzer pin as well, and then there's like forwards, backwards, left and right. And then in the stop, and then in the main loop I'm just saying go forward and delay for half a second. So it's going to do that going forward for a second, and then so let's say that I've got a problem in here. Let's remove one of the semicolons from there and try and compile this. This is going to generate an error because I've not written my code properly. And what I want to show you on here, oh, it's saying that there's a plug a device in, so let's just do that. Just so it can actually try this out for reals. I have my cables here, so that's not a problem. It's got this nice old-fashioned chunky connector there. Right, so if I compile this now, you can hear the motors slowly whirring round. We should get an error. There we go. So we've got the error. And there's this nice button that says Fix Error. So it's expecting that little semicolon before delay. It knows exactly where the error is. And we can click on this Fix Error. And you can see here it's opened up this Arduino AI assistant. And this is like any kind of regular, Claude Code or ChatGPT. If you've used VS Code before, this is kind of familiar to you. So you can actually say just apply the fix, and it'll go and put that little fix in there. It'll now compile. It's compiling this using the a web backend as well, so there's no compilation going on my machine. If I now upload this, it should stop doing that for a second once the code starts to upload. And there we go. You can now see it's uploaded it and it's working fine. So there we go. And that's just like a regular Arduino Uno non-Q version, like a revision 3. I wanted to show you that because the AI assistant is like a newish feature, and that's something that when I looked at this I was like, oh, that's new, I've not seen that before. This is quite cool if you work in education and you don't want to install like the Arduino IDE on lots of machines. You can just connect through the web. You just need a powerful enough machine like a Chromebook or whatever to access this, and you can have a number of different things in there. I think the plan that I'm on, I have up to 25 things. And again, a thing is a device, a sketch, and it has online updates. So if I connect this up, I can actually flash updates. I could flash an update, for example, to that device that's behind me. I've not got any kind of USB connection to it, that WeatherBot. So that WeatherBot's currently online. If I go to the sketch for the WeatherBot, not sure what that's called actually. In fact, if we go for things, we find the WeatherBot thing there and open that up. I think you get 3 tabs. You get the device tab, the sketch tab, and the metadata tab. There we go. So the setup is it's kind of sharing 2 variables with the cloud, so the humidity and the temperature. So it's broadcasting those over the Wi-Fi to the Arduino cloud MQTT broker, so it can see that it's online. And you can even connect this up to things like your smart home, so your Alexas and Google Homes, and then you can even forward data as well and have triggers and things. The sketch, we can edit the sketch using that cloud-based editor, And if I were to change something in here, so let's say let's add in a new serial.print let's do print line, and let's say weatherbot online. So really useful value add there. If I now click on upload, it can actually do an online update. It can do an over-the-air update to that Arduino. That's quite a cool feature. I quite like that. So it's compiling the code, it's then going to send that code over to the Arduino. The Arduino's got enough space to be able to store that temporarily and then flash that to the board and then do all that while it's online without me having to physically be connected to it. So that's quite cool. As you can see there, it's now doing that. It's now starting the over-the-air update attempt. It's uploading the binary file, and yeah, it'll just take it a couple of minutes to do that. And we can basically just leave it to it. I don't have to be connected to this for it to finish. It's fantastic to do this. It'll do that in the background. So that's quite a new feature. So again, we can use the Uno Q to do this kind of editing. We can also program the Uno Q just like a regular Arduino device that has Wi-Fi as well. Cool. I'm going to show you a really cool demo in a second as well. So it's even rebooting the device there as well. And once it's done that, yeah, over-the-air update complete. Now we can't really see any difference there, but we can go back to that dashboard and see, is that dashboard actually showing some values on there? So if we go back to that live stream demo, as you can see there, 19 and a bit degrees. So yes, the aircon's set to about 20 degrees, so you can see there. I think I had the door open. Yep, about 1:30 had the door open, so it got quite warm, and then it's cooled down again. That's interesting. It should be reasonably flat. Cool, so that's that demo. Let's go back to the Uno Q, and what I'm going to do is I'm going to load up a new sketch on here. So I go back to the App Lab, and we're going to do the find it, the Uno Q pin toggle. This is quite a cool demo to run. So the pin toggle is going to show this little web page with the Arduino Uno there, and then you can switch on and off each of the pins. You can make them high or low from a web interface, and it's going to use the web UI brick, and it's going to use a combination of Python on the sketch on the Uno Q as well. So let's just run that. Confirm and replace. It can only run one Docker container at a time, one brick. No, one app, I should say, at a time. You could run multiple containers if they're different bricks, yeah, but it kind of manages the whole thing as one app. So it's got the containers stopped there for the other one. It's going to then compile the code for the MCU, for the microcontroller. Once it's done that, it can then interpret the Python code and bring up that Docker container. Through some comments there just while that was happening. So was there a question there about how much does it cost for the board or for the cloud? I can go back over to the cloud thing just temporarily and just have a look at the plans. I don't think it's very expensive. I go to plan usage, for example. Does it tell me on there how much the plan costs? Let's have a look at Arduino plan cloud plans. Just because you asked. So I think I'm on the Maker one, so that's $49 a year, is that? Yeah, that's yearly, so monthly $699 per month. If you're a business, so a team or otherwise, it can be $100 a month, but you get a lot more things, a lot more data retention. So I get 3 months data retention for any of the data that I send there for my dashboards. If I don't do anything with that, it'll just be hosted there. If you're a school, then you can have 5 to 50 for 20 per member per year, which is pretty good value. 50 to 100 or 101, so that's 15 per year based on that, with a 30-day rolling commitment to that. But they do have every now and again, so they've even got a free version, so you can start completely for free if you wish. You can have 2 things, 5 variables, 1 day of retention. You can do 50 records per day. You can't do any triggers. Triggers are like if you want something to happen, like send an email, for example, it can trigger that. You can have dashboards. You don't have any advanced APIs or widgets on the free version. So you pay your money, you get your choice on that one. It's not something that they're essentially pushing. It's just something that's available to you if you wish that. You can build your own. Cool, so that's now running. So this is the Arduino Uno pin toggle. We can go to the Python code on here to see if there's anything happening. But really what we want to do is go over to here. Let me just refresh this. So this is a web page. It's quite dynamic as well. If I squish that down, it sort of resizes nicely. And I've actually got an LED plugged into the Arduino here, that big red LED there. So if I go to pin 13 and I toggle that on, I can click on and off, on and off. And they also have at the bottom of the screen there 2 LEDs, RGB LEDs. So I can toggle on the red, and just about see if I hold that up. The red LED is on, the green LED is on, and then the blue LED is on, and you can kind of mix and match the colours to make all the different variations of that. And they've got a second one as well, so you can have like both the reds on, for example. You can see that, and you can have basically all of them on or all of them off. But it's just a nice demonstration of the web brick and code that speaks between the Python code and the Arduino sketches. Excuse me. Let's have a look at that in a bit more detail now. So if I go back over to here, let's have a look at the code itself. I'm going to stop that from running first of all. And then let's go back to the examples there. Let's go back into it. So that was the Uno pin toggler. So again, the assets on here, it's got quite a few assets because this one has a web page. They've also got the actual web page itself. So there's the Arduino logo, the board image. So Arduino toggle SVG, we can look into the images and we can actually find that. There it is. There's the logo, there's the license and the toggle button. And then they've got some JavaScript. They've got some quite extensive JavaScript there that handles the kind of interaction when you click on that little button. It does all the animations and so on. I'm not a big JavaScript developer myself, so this looks like a lot of just not a great. I don't find JavaScript a great programming language, if I'm honest. It's got some really weird quirks to it, but yeah, that's my personal take on it. And there's the style sheet. I do know style sheets, so that's all the kind of colours and font sizes and so on for the web page. Then we've got the Python code. This will be quite straightforward. So we're bringing in JSON, so we can do JSON, which is JavaScript object notation. And we've got date time, we've got the utilities, the bricks, the web user interface brick. We then set up this little list of key value pairs. So D21 active low false, so that's the state and whether it's true or not. And then there's the name of it as well. We had a thumbs down there. Does somebody disagree with my take on JavaScript? You're a big JavaScript fan, I take it. There we go. I'll thumb back up again. So yes, we got we initialize the web UI with this little variable here, and then we basically just set up. So what is the time now? We've got like a normalized state function there. We've got ensure dictionary is instance thing there. What I'm looking for in here is the bridge command, so that's probably going to be right down here. So there we go, UI, on message, pin toggle, and then expose the API, get and states, so we can interact with those states. But when we click a button, the JavaScript sends this backend a message, and then we can receive that message on that get states thing. So that's basically run when somebody clicks a button. So let's have a see if there's anything else on there that I was looking for. So this bridge.call, that's the line that talks to the microcontroller. So we now go to the the sketch folder and have a look in this Arduino sketch. So we can see up here we're bringing in the Arduino router bridge. That's the thing that talks to the main Python code there. We set up some pin entry structures. We've got the same kind of thing there. So if we pass in D21, we know that that's D21 digital pin 21 versus analog pins. And then we've got the different RGB LEDs as well. And then if we're told to switch one of these on, so this bridge provides the connectivity between the Python code and the Arduino for setting the pins. It then goes through that little array of pins and basically just sets them high or low depending on whatever value we've told it to. So you can see there, we don't even need to have anything in the loop. It's just this setup code, and that bridge provide and bridge begin is the connectivity between the two. So that's the code for that one. I thought that was quite a cool one because it looks really pretty and it's quite interactive. You can switch, I'll go back over there again, you can see you can switch that LED on and off. It's like a really elaborate way to do that. I'm not running the code now, so obviously that's not running. If I actually refresh that web page, it'll be off. There we go. And if we go back to here, we press run, it does have to recompile the code. I find that a little bit frustrating, that it should know that no code has changed and therefore just run the code as it is, but it doesn't do that. Other things of note on here, I go back full screen on that, is you can see it runs that Zephyr OS. So Arduino are getting rid of the embed platform, which is like a way of compiling code. It's like a layer of abstraction, so you can write one set of Arduino code and it will run on all of their boards. So behind the scenes, embed's been used for a long time, and this Zephyr OS will be used for some of the newer boards, as I understand it. It brings a lot more speed, particularly with compiling on there. So there we go, so that code running again. If we go back to our web page, hit the reload, we've then got the nice user interface. There we go, and we can toggle that pin on and off again. If I click on that pin 13, there we go. We can turn that LED on off. There's an awful lot of stuff going on there. Right, one of the other examples I wanted to show you as well is if we go back to our examples. So let's go for the accelerometer, real-time accelerometer. Let me show you this one. So this real-time accelerometer, this is going to use the web user interface again, and it's also going to use the motion detection. So I have got connected up to, if I load up this overhead camera here, I've got one of these modulinos attached. This is the accelerometer modulino, and these are basically just little I2C or quick connected modules. So it's got a little accelerometer on there and gyroscope, and it's connected up by a little quick connector there. So if I run this code, so yep, confirm and replace, we want to replace the app that's currently running. You can see it's going to stop all the containers there. So if you log in onto the machine on a terminal and do like docker ps to see what's running, you'll see all these Docker containers sort of vanish. You can see there it's going to bring up all the other ones. The library modulino has been automatically added from the sketch. The message pack, and then the STM Arduino. That's the that looks like a laser rangefinder. I'm not sure why that's there. Anyways, so once this turns sort of that bluish colour again, we're good to go, and we can play with this one. This is quite a fun demo to do. Okay, takes up hardly any of the memory of the MCU. And here we go. It should turn that nice. Is that teal? What's the name of that colour that it turns? There we go. So that's now that top teal colour. We can now go over to the web page, and let me do that split screen again. It's going to update the, just give that a refresh. Wait for that to load up. There we go. So what this is showing now is this real-time accelerometer, and it's got this detected movement thing as well. Snake, wave, up and down, and idle. So currently it's detecting that the modulino is idle. If I tap this a little bit, you can see there that it's thinking that that's like a snake. If I wave this around, is that a wave? Yep, it's detecting that's a wave. If I move this up and down, it's detecting that that's up and down. And if I just leave it, it'll detect that that's idle. So it's interesting that using a different lot of combination of components here. We've got the web interface doing the nice graphics on there. We've got some real-time data acquisition from this little sensor via I2C. If I move this down so we can see it there. If I sort of shake this side to side, that's the snake. The wave, I think, is a bit more of a... Is that wave? It's difficult to get this right. Sort of side to side, I think. And up and down is just like... I think you'd expect up and down. There we go. There's a lot of stuff going on there, a lot of inference. I just like the way that they've brought that together. Sensors, AI, web graphics, and then the power of Python and the data acquisition from the sketch as well. So let's have a quick look at this sketch. So if I go over to here, files, that's what I need to click on. So if we look at the assets on here, again, because it's got a web page component, there's some JavaScript in there. The Python code, bringing in some pandas. So that's some data science stuff, time collections, DQ. Then we set a confidence level, motion detection brick that's being brought in there. So you've got motion detection, we've got the web user interface, and then we've got some logging as well. So then we create a pandas data frame, and this is how it's going to store all that data. It's kind of like, imagine a spreadsheet or a little database in memory. That's what a data frame is. It's like rows and columns of data. And we need to store and track the data because the motion is, it's kind of a cycle, and we're looking for, is it like this kind of cycle? Is it nothing's happening at all and that's idle? So what does that look like? We need some time data for that. We will then initiate that web brick. We then expose a simple HTTP API to get to the last detection. So that's the detection data frame to dictionary. Exposing the API, so that slash detection is where that sits. Unconnect. There's a little lambda function. That's interesting. A lambda function is like a regular function but without a name. You just use it once and then it's done. So you can have like a block of code there for that. And then we're doing some debugging on there as well. If the motion is detected, then we can classify, is it idle, snake, up, down, or wave, and we pass in. So we're essentially setting up the classification for the idle to that idle word there, and then we send the message movement and the dictionary for the records, and then we do that registering the movement callbacks on the blocks. So which one of the four is it? We set up how many samples we want to take. They go into this DQ, which is like a little queue of things, he says, and then we get samples. It's going to return that list of samples. Record sensor movement, so it's going to grab this from motion detection, accumulate samples. I'm looking for that bridge call again just to see if that's anywhere in there. And then yeah, logging info started up. So we look at the sketch. Let's have a look at what that looks like. So it's going to bring in the Modulino for the motion detection, so accelerometers X, Y, Z axes. Previous milliseconds, interval 16, so that's how long to wait between reads, and has movement. So if there's no movement available, that just gets set to 0. We set up the bridge so we can talk to the Python code. We start the Modulino module, and then while there is not movement, begin. And that waits a second. And then if current milliseconds minus milliseconds is greater or equal to interval, then run this code. We store the previous interval milliseconds just to update that little check. And then has movement update. If movement equals 1, then we get the values, and then we bridge notify. We send those data back over to the Python code. So there should be a corresponding notify block in here somewhere. I didn't catch where that was, but that's in there somewhere. Let's see if I could see that. Is there a find function on here? So yeah, there are some, there's a find function. Let's see if there's a notify. So that does say the callback functions handle movement detection. I would have just thought you would have some kind of notify word. But yeah, I'm not familiar with this yet. This is something I need to learn a lot more of to understand how that works. So that's quite a cool one. So we've got some real-time data, we've got Python code interpreting that, throwing it through a machine learning model, and then classifying what that data looks like. Cool. So I think that's everything I wanted to cover off on there. One of the things I was going to try, it depends how brave I feel on this, is basically running this as a robot. So let's disconnect this. So this robot here, I wanted to see, will the 9-volt battery be enough to power the Arduino Q? So this is a SMARS robot. These are what I started my YouTube career playing around with. So this is a motor shield. I think it's called a Fundimoto shield, and it allows you to connect up 2 motors and a bunch of servos, and it has some nice pinouts. It's got a speaker on there as well. Just need to disconnect these. I should have done this before the show started, but I wasn't sure whether we'd have time to do that. So there's 1 motor, there's 2 motors, and I just need to unplug this shield. So you can see there's an original Arduino Uno revision 3. I just need to slide that out. Let's slide in our brand new one-of-a-kind Arduino Uno Q. Let's put our shield on. And then let's just connect up all these pins again. So I think they're the let me just make sure that I know they're the power ones. There we go. So they're going through the side. There we go. Right, so just need to fasten up fiddly to do this. Honestly, I made these cables literally just long enough fit in there. It's kind of a two-handed job. There we go, there's one. There's 2. I do like these screw terminals. They make a really nice connection, but you don't need to commit to it. You don't need to solder it in there in place. But they do come out occasionally if you don't screw them in properly. And the best kind of cables are the ones that haven't got the multiple threads of cable. They're just like a solid piece. They seem to screw in easier, but the black cable's single core. The red cable's like multiple core, so the red one's a bit fiddly to get in there. It's just what I had available. Right, and then finally, if you want to know how to build these SMARS robots, there's an absolute ton of videos that I've done on my YouTube channel and also on Kev's Robots. Just search up for SMARS robot. It stands for Screwless Modular Accessible Robotic System. And he's dropped. I always drop something every stream, don't I? That's guaranteed to happen. There we go. I'm also trying to keep this like on screen so that you can see as I'm doing it too. So it's a bit of a funky angle for me. Right, okay, so let's plug in the ground. So this shield does have a voltage regulator that drops the 9-volt battery down to 5 volts, and then the Arduino Uno Q has one that drops it down to 3 volts as well, 3.3 volts. Goodness sake. And really what I want to see is, will it actually power up the board, or will it fry it? That's why I'm doing it last, just in case we have like a meltdown. Here we go, let's plug this in. Well, the good news is I can see that the LED is lit up on the Arduino Q. So there we go. So you can see that the blue LEDs are sort of flashing in there. We've got the blue LED there, which tells me the Unix desktop has booted. So if we now go back to the app lab and just give that a I'm going to quit and come back into that. Let me just do that again. We should see momentarily that we have there we go, network. We can connect up to our Arduino Q, and it's actually in a robot. Now, whether I can actually make the code work on this is another matter. So it would simply just be me loading up the code that I created earlier. So let's go to here and let me load up the sketch. So the sketch is that SMARS Uno Q. So that's the code that we need to load up onto. Let's just copy all that code, go to our app lab, go into our test program, go into our sketch, paste that in. So it's not doing anything fancy, it's not connecting up to the Python code or anything like that. It's literally just going to make the robot move forward. I can actually hold it up here. So this code that you're seeing now is being compiled on this little robot that I'm holding in my hand here. And when it runs, you'll see it sort of jolt forward. There we go. I think one of the wheels is a little bit sticky, or maybe I've just not got that plugged in properly. Yeah, I think one of the pins must be a little bit out. One of the wheels, only one of the wheels is spinning around there, but it'll be that mesh of wires at the back there that I very hastily put together. But there you go, we've got a robot. We've got the Arduino Uno Q running in a robot. So the next thing to do that would be really cool is to put the webcam on the front, and then we could have some kind of image detection. We could do all kinds of cool stuff there. But the fact we've got a Linux desktop running in a tiny little robot this size from a 9-volt battery is pretty cool in my opinion. So I'm just going to pull the power on that one. So that doesn't be making that noise. There we go. Cool. So I hope you enjoyed that little one there. So again, we can what is interesting on these, if I pull that power back in just temporarily there, screw that in. What I'm interested to see is, does the sketch that we've uploaded load right away, or do you need to have the desktop loaded and then the app running on there? It looks like you need to have the app lab code running the container which contains the sketch that's on the board. The little reset button on the board doesn't reset the desktop, it just resets the MCU. So that's another little thing I discovered on there. So there you go, there's our Arduino Uno Q based robot with just one wheel running around there, and that's the SMARS robot, and that's a Fundimoto shield that's on there as well. There we go. Let's just whip out. Cool. Well, let me get back to the slides. I think that was all the demos I wanted to show you there. Cool. So if you want to join our Discord community, we have a really active Discord community over on kevsrobots.com/discord. You can get a free sign-up link for that. Just check your email, your junk folder if you're not on there. I'll share some pictures of this that I built as well as I'm building this out over the next couple of weeks. I want to be able to run ROS 2 in this little SMARS robot and do some really cool things with basically take it up a notch, make it a bit more interactive than it has been as a project to date. If you want to follow me on social media, I'm on all the social platforms. You can find me on Threads at Kevin McAleer at threads.net. I'm on TikTok at Kevin McAleer6. I'm on Instagram at Kevin McAleer. I'm on X at KevsMac. And I'm also on Mastodon at kevsmac at mastodon.social, and also on Blue Sky at kevsmac.bsky.social as well. So if you're on any of those platforms, give me a follow, say hi, share a project that you're currently working on. That'd be really cool. And if you want to join me and support the channel, you can do that in a number of different ways. You can do that as a super chat if you're watching live now. You can do that as a super thanks if you're watching this on replay. If you want to join the YouTube membership program, once you've subscribed, it gets replaced with a join button. You can click on that for a small monthly fee. Or if you want to buy like a one-off coffee because something's piqued your interest and you want to support the channel, you can do that by buying a coffee. Go to kevsrobots.com/coffee for more information on that. And if you want to support the channel, here's the people who have done exactly that. So over here on the left hand side, we've got Charles Stevenson, who bought me 3 coffees in the past month. Marie Louise Mayer bought me a coffee as well. Thank you both for that. And then we've got a number of different members. We've got Pietro, Michael, Warren, somebody who wants to be anonymous. We've got Silicon Fiber, Marie TKD, Jeff Johnson, DN Corty, Marlene Brent, and Tom. And then on the YouTube side, we've got Marie Mayer, we have Pete Barnes, Dale from Hybrid Robotics, Orktrad39, Warren Packard, got Brian, Pierre Eves, Bert, Michael, Steve, Ford, Bello, Johnny, Stephen, John Paul, Cassie, Johnny Bates, and of course we have Tom. Thank you so much for supporting the channel. It means so much to me that you continue to support the channel. Thank you very much for doing that. And let's get back to the final slide on there, which tells me the spinny logo, tells me it's time that YouTube will be recommending a video over here for you to watch next. So definitely check that one out. It's been handpicked by the algorithm just for you. It thinks it's the best video for you to watch next. So definitely check that out. And I thank you all for watching, and I shall see you next time. Bye for now.